Okay, we're going to pick this up with barium. All right, and this one's going to be pretty long because barium is number 56 on the periodic table. So that means we have 56 electrons that we need to place. And let's see what we remember. Okay? So this is page 6.
My brain doesn't work.
Okay? All right. For barium, which is right here. All right?
Why did I write it in the
All right. Still can't see both. Okay, here we go. So we're going to start out at the top, and this is your first row, so first energy level, and this is 1s2. Okay, so put 1s2 right there. That gets rid of the first row. Next row, second energy level, so put 2. This is your S sublevel, and there's 2 spots right there. And then you're going to keep going over till you get to the P. So this is 2p6. All right, and then that eliminates your second row. Third row, okay? So we got the 3s, and there's 2 spaces right there. And then over here, you got the 3p. So this is 3p6.
Oh my gosh, I get this now.
Yes, it's happening.
I'm here.
All right.
You understand it. You don't even have yours colored.
Then we have the 4s, and there's 2 spaces right here, so 4s2. And then what do we know about the D sublevel?
It's
Abby.
one like up, so it's 3D10.
Yes, if this is the 4th row, the D sublevel is always one behind. So this is actually the 3D10. And then you got over here, you got your 4p6 because you jump back up for the P. This is the 4p. And then you got your, wait, where are we at? 5, yeah. So 5s2. And then what D sublevel is that? 4d10.
Where's barium?
Barium's BA. Second column. All right. So 4d10, then 5p6, and then barium is the second one over in the 6th row. So you have 6s2. Okay? 6s2.
No, because you count the one that's on 2. Yeah.
Yeah.
But you don't.
So, yeah, barium is the second one over. So that means it has 2 electrons in the S sublevel. So you got to put
So if
6s2.
it was cesium, or however you say that, it'd be 6s1.
6s1, yeah. Zan?
For lanthanum and actinum, would those count as under D or under F?
Those would be under F. But, okay, I'm going to say this. The reason why the F is so confusing is because depending on which periodic table you look at, you may get a different answer.
Because I was doing neptunium or however you pronounce that.
Yeah.
And I got 94, but it's on 93 because I counted 10 D, except it's only 9.
Yeah.
Just do 9.
So that one would end with 5F5.
That's what I have, but that's what I have ending. But what, for 6D would be 69.
No, it'd still be 60-10.
There's only one.
So, yeah. Yeah, that's why I'm never going to test you over the F. we may do like a couple just examples just for fun, but you'll never be tested over the F. Okay. All right. So that's barium. And for neptunium, okay, I'm just going to do this real quick. So everything up until barium will be exactly the same.
So that entire thing needs to go down?
Yeah.
Yeah, it'd be the same up until that point.
Can you just like go to that point?
Well, I'm going to show you a shortcut here in a minute.
That's on 93. It's very low.
So do you want us to write all this down or no?
I am.
It's up to you. You can write an arrow and just point down or whatever.
Wait, I need to read it.
All right. So when you get to 6s2,
Wait.
and we're going to neptunium now. So neptunium is down here. So again, it's the same as barium's up until that point. Now, at that point, you have the 6s2. Then you jump to the F. So the F is down here. This is actually the 4F14.
So it's 2 behind?
It's 2 behind. That's one thing you got to remember. The F sublevel is always 2 numbers behind the row it's in. So this is actually in the 6th row. That'd be the 4F. This one would be in the 7th row. It would be the 5F. So you got 4F14, and then you jump back to the D sublevel, and that is the 5D10. And that takes us over to here, basically over to Mercury. And then you jump back to the 6P6. And for the last part, you have 7s2. And then you just have the 5 left. So you got 1, 2, 3, 4, 5 to get to neptunium in the 5F. 5F5 would be the last part. Zan?
Count 57 and 89 as lanthanide and actinide. Wouldn't that equal 15 different electrons?
Don't read too much into that. So, okay. Here they're going to count as F sublevel elements. On some periodic tables, it actually shifts it over so that you're going to lose 2 out of the F. You're going to have 14 electrons or 14 elements regardless, but depending on which periodic table it is, it may be 14 different elements. Like it might shift 2 over and then pull 2 out of the D to be able to make it, but it'll have 14 regardless. It just might be a different 14 depending on which periodic table it is. That's why you'll never be tested over the F. Okay, like we're doing this example right now, but I'm never gonna like put this on a test where you would have to do one on your own. Jimmy?
So you know how, I'm sorry, you know how in math, whenever you have like a super long problem,
Yeah.
you can like simplify it?
I'm about to show you.
Awesome. Thank
Okay.
you.
So there is a way to write an abbreviated electron configuration, and it's way shorter. Okay?
I bet I know how you do
I'm
it.
sorry.
I bet you don't.
Why? You think I don't?
But I'm going to tell you, and then you tell me if this
Can
is
I
what you're
guess?
going to
Wait,
say.
can I guess real quick? You add all the S's together, and then you add the exponents together.
No.
You,
All right.
See,
So,
That was a good guess.
listen.
That's
This is how you do it. Okay? And on a test, if I ask for the full electron configuration, give me the full electron configuration. If I ask for the abbreviated, then give me the abbreviated. Because I will ask for both at different times. All right. So on your periodic table, okay, the question that we're looking at right now is cobalt. And cobalt is right here. Okay? All right. Does everybody know, maybe you don't, maybe you do, that this column right here is the noble gases?
Yeah.
Do you know this?
No.
Okay.
I'm going to
How are
label
we
that.
supposed to know
All right, well, if you did not,
Wait, including helium or no?
Yes, Jimmy, that's the
yes. And that's one of the reasons why helium fits over there, because it is a noble gas, but it still only has 2 electrons in its outer shell, which is why it also kind of fits over in above beryllium.
So it's weird.
It is. It's a special circumstance. So yeah, helium is a noble gas. So you're gonna keep it over here in that term, but for electron configurations, you got to consider there is something here to count whenever you're writing the configuration out. All right, now for cobalt, this is what you're gonna do. Cobalt's right here. It's in the 4th row. Everybody see that? 4th row. Okay, go up to the 3rd row. Go all the way to the end, and whatever noble gas is right there, which is argon in this case, you are going to write that symbol in brackets.
Wait, where is argon?
Argon is the noble gas. It's the row above cobalt all the way to the end.
Is this what your 3rd row?
Yes, it's much easier. Now, what that tells me is that from that point, okay, to that point, the electron configuration for cobalt is the same as argon.
Wait, so what do you write in the bracket?
You would write argon, AR.
You just write the symbol.
Yes.
So then after that, would you write the configuration?
Yeah, from that point on, you write whatever comes after argon. So then you would write 4s2 and then 3d 1, 2, 3, 4, 5, 6, 7 to get to cobalt. So 3d7.
So you basically skip everything.
I'm so
Yes.
That's so much easier.
That's the abbreviated configuration. Okay?
Okay, I have a question.
Yes.
How come if in the D section, why didn't they just move it up one if that's part of row 3?
Because it's built off of the way that the electrons fill the sublevels, not in order of like energy level number. So one thing you have to remember is that electrons are going to arrange themselves in the atom in a way that's most stable. Well, most stable is not always filling in order of energy level number. It's actually filling in order of lowest energy. So sometimes you may have a higher energy level number, but the energy associated with it is actually higher. Like, let's say, for example, if you had like 3d10, well, there's 10 electrons that are associated with that. Well, 4s2 is actually lower in energy because it only has 2 electrons. It's a higher energy level number, but it only has 2 electrons that are associated with it. So it's actually a little bit lower in overall energy, even though it has a higher energy level number. Okay? So the periodic table walks you through in order of the way that it fills up, okay? Not necessarily the order of the number. All right, let's do one more abbreviated configuration here.
Wait, I want to try that.
So let's do silver.
Isn't that AR?
Silver is AG.
Oh, it's not it.
So silver's right here. Okay? Now, what noble gas would I go to?
Krypton.
Krypton, KR.
Ooh, Superman's getting mad at you for this one.
Wait a minute.
Right? Isn't that what Superman doesn't like?
Kryptonite.
Oh, isn't that the same thing though?
No. Kryptonite is fictional. He came from the planet Krypton.
Oh.
Wait, anyways.
Huh? No. The planet.
And you say I have stupid questions.
Kryptonite.
Kryptonite is a rock. It's fictional rock.
I've never seen
Well, I've never seen.
All right. So, silver right here. From there over, listen.
I'm just kidding.
From there over, you're going to write 5s2
I already got it.
and then
49.
4d9.
No. Now, okay, give me a test over it. I got it.
Okay?
Macy, I highly doubt that.
Oh,
All right.
literally give me a pop quiz. That.
Now, let's look at these down here at the bottom. We're going to do these together, and then I'll leave the rest that you guys can do.
Guess them and then you tell us
All right.
the answer.
Now, the bottom says determine which of the following electron configurations are not valid. State which rule has been violated. So this first one, let's just read this and see if there's anything wrong with it. So 1s2, 2s2, 2p6,
Found it.
3s2, 3p6, 4s2, 4d10, 4p5.
I already told you.
I will tell you there is something wrong with it. What is it?
It's literally the second.
What's wrong with it, Maisie?
The row 2 S2 is 9. No.
That's not what's wrong
I
with it.
know, wait.
Oh, that pop quiz is going really well.
Jimmy, shut up.
Ethan, what'd you say?
Wait.
Needs to be 3D10 instead of
Yes. Right here, this is 4d10. It should be
So it doesn't matter what order you put it in?
3d10.
Why can't it be 4D?
Well, because the 3d comes before the 4d. So you can't put electrons in the 4d before you get to the 3d.
Then why did they do row 1 S2 and then they did? Oh my god, I'm so dumb.
Well, remember,
No, just forget what I just said.
the
I'm
D
dumb.
sublevel is always one row
I was
behind.
thinking there was one. Yeah, I'm done.
Okay.
Just ignore me.
Okay, I'll see you Tuesday. Second
Okay,
All right.
Next one.
Pop quiz.
Right here. 1s2, 2s2, 2p6, 3s3, 3d5. Abby, what's wrong with that one?
It's supposed to be 2d5.
So with this.
Wait, doesn't it go back? Just kidding.
Just
That one's actually, that part of it's actually
I
right.
thought the D was, but like the D level was supposed to be like behind.
Well,
Is that not what we
there
just did?
is,
no, Abby.
there's
I'm so confused.
something else that's
It has
wrong.
to be
Hold on.
I was
Oh, I
right.
got it.
Ben, what's wrong with it?
S2, S3 though.
Right. You cannot have 3s3. That would have to be 3s2. Because the most that can hold is 2 electrons.
Wait a minute, I did something wrong.
Oh, so this pop
You
quiz is
couldn't be a
going
3D.
No, I did something wrong on my.
What did you say, Zan?
You couldn't be a 3D if you were 3S.
Technically, probably not. But the 3s is the one that for sure is wrong. All right. I will say this. There are some books that don't write it the way that the periodic table actually has it out. They will write it in order of number. I don't really like that, and I try to stick to this as much as possible because this actually I think is more accurate, but it's more the 3s that's wrong here and not necessarily the 3d. Okay. All right. Maisie.
So on the 2 rows, on the first one, is it row 4? On the top.
Wait.
On the periodic table, right here, is this row 4?
Oh, yeah. Yeah, it'd be 4F. Second would be 5F.
What are you talking about?
All right. Number 18. What's wrong with that?
Alright.
Right.
Should be RN.
Radium, Ra, is not a noble gas. So this should be Rn 7s2 5f8. Okay, you can only use a noble gas for an abbreviated configuration.
Oh, wait, really? You think you said anything one?
No. All right. Number 19, you got krypton, 5s2, 4d10, 5p5.
Oh, I found it.
What's wrong with that? Macy, what do you think?
Is it the wrong number? No.
No, because you don't even know which element this is actually writing it for.
I'm confused.
Is there anything wrong with this?
No.
Ben?
Jimmy, shut up.
the krypton is in row 5.
All right. No, krypton's in row 4. There's actually nothing wrong with this. This is fine. So number 19, that one's okay. And then number 20, you wouldn't know this unless I told you. An element cannot be its own configuration. So you can't, if you're writing the configuration for a noble gas, you can't just put that noble gas in brackets and leave it. What you would have to do, like if I were writing the configuration for, say, xenon, I would have to go back to krypton and then write that last energy level. Okay, that's just a rule. Okay, like there is a rule that says that an element cannot be its own
That's
configuration.
kind of silly.
Well,
Why can't
you can have your own opinion, but I don't have an answer for
In my
that, Jimmy.
opinion,
Okay?
atoms are
I'm just telling you the rule. All right. So there you go. Okay. All right.